So I think I've shared my screen. Let's move on. Yesterday we agreed. Today we discuss linear motion. And then we do a few examples on linear motion. So what are we expected to know in this linear motion? Fortunately or unfortunately, there are very little to know. We know that speed is equals to distance over time. Speed in kilometers, distance is in hours. The units of this will be kilometers per hour. Speed is equals to distance over time. If distance is in meters, distance is in time is in seconds. So we have the units meters per second. Also, we should know how to convert how we change speed from kilometers per hour to meters per second and vice versa, meters per second to kilometers per hour. After knowing that, then now we bring in the aspect of a few details. We bring in relative speed. Relative speed, we have two aspects. We have bodies which are approaching each other, or they have movement in opposite direction. Here we say it is speed 1 plus speed 2 equals to our relative speed. The bodies which are moving in same direction. If the vehicles are moving in same direction, relative speed is equals to speed 1 minus speed 2, the difference between the two. That is relative speed. Then, what are we expected to do in case of such a question? We are expected to read and do a better interpretation. So what are we expected to do? We are expected to read a different scenario and then you move on. That's about a question that is asking on the speed, relative speed, and then take good note of time and how to find now overtaking in time. OVT is equals to distance between the two over relative speed. That's the time taken for the faster vehicle to catch up with the slower one if they are moving in the same direction, or the time taken for the two bodies approaching each other, taken for them to meet. It is distance. Always we find the distance between the two and then we divide it by 2. But in this case, both should be in motion. Both vehicles should be in motion. Now from there, we also have graphs. We discussed two graphs in mathematics. That is, we discuss distance time graph, which is not very common. This is the graph of distance against time. So it has maybe a straight line. So how can we describe this motion from O to A and then to B? That from O to A, it means this body is moving at a uniform speed. From O to A, the body is moving, the vehicle is moving at a uniform speed. From A to B, the body is at rest. Time is moving, but it is not moving at all. It is not covering any distance. Then B to C is the same as the body is moving at an average speed. That is on distance time graph. So the gradient of this line would give us a speed, which is measured in kilometers per hour or meters per second. That is on distance time graph, which I've said is not commonly tested. We also have a velocity time graph. In a velocity time graph, this is a graph of this is the graph of velocity against the time, and now the distance from O to A, the body is accelerating. From A to B, moving at uniform speed, velocity. From B to C, still it is acceleration. From C to D, it is decelerating. Deceleration, that is which is a negative acceleration. And then we worked with acceleration is equal to, somebody wants to talk, final velocity minus initial velocity divided by time taken for the change. This is all that we are supposed to know. And how do you find the distance? Distance in a velocity time graph, acceleration is equal to the gradient. Maybe the gradient of OA will give us the acceleration. The gradient of B to C gives us acceleration. Gradient of C to D gives us acceleration. And now the distance covered is equal to the area under a graph. This is, we have covered everything that you are supposed to know, all aspects that you are supposed to know when it comes to linear motion. And now from there, you start thinking on how to answer questions. Any aspect that, anything that I've left out so that we can have a look at it. Good. Let's get back to now find one question so that we can address under linear motion. Let's start with maybe a simple question. Linear motion. Trial 1, paper 1, question 19. Trial 1, paper 1, question 19. Trial 1, question 19. This is the question that we are going to address. Trial 1, paper 1, question 19. Good. Brenda, read the question.
A bus left Nairobi at 7 a.m. and traveled towards Eldoret at an average speed of 80 kilometers per hour. At 7:45 a.m., a car left Eldoret towards Nairobi at an average speed of 120 kilometers per hour. The distance between Nairobi and Eldoret is 300 kilometers. Calculate A, the time the bus arrived at Eldoret. B, the time of the day the two met. C, the distance from Nairobi where the two met. And D, the distance of the bus from Eldoret when the car arrived at Nairobi.
Okay. These questions, they demand our thinking. They demand our application of what we see and proper analysis and clearly underlining what you are supposed to know. I want to advocate one way of analyzing this question. Bring it to an activity. Bring it to just a diagram. Then you bring the information there. Bus left Nairobi at 7 a.m. and traveled towards Eldoret. So I want to say there are two towns. One is Nairobi, another one is Eldoret. A bus left Nairobi at 7 a.m. and traveled at an average speed of 80 kilometers per hour. At 7:45 a.m., a car left Eldoret. So we have a car which is leaving Eldoret at 7:45 a.m. and traveling at an average speed of 120 kilometers per hour. Try to shelter your thinking in a way that you cannot leave out any information. Then the distance between Nairobi and Eldoret is 300. The distance we are discussing here is 300 kilometers. Calculate the time. Try to bring all the information, all that you know, in a diagram. It's an activity that will enable you to think. The time the bus arrived at Eldoret. So it's kind of straightforward. It's maintaining an average speed of 80. So we calculate time. What is time? Time is equals to distance over speed. Our distance between Nairobi and Eldoret is 300 divided by 80. So we have 3 hours and 45 minutes. Is that true? 3 hours 45 minutes. But what we are asked is the time. Yes, this is the time. So time will be equal to the starting time, which is 7:00 plus 3 hours and 45 minutes. So the time of the day the bus will arrive in Eldoret is 10:45 a.m. Any question there? This question has not involved relative speed, has not involved so far. Then now we move to, so it will arrive at 10:45. So it is the time taken from Nairobi to Eldoret. Then you add to the starting time. The time of the day the two met. This one now is involving relative speed. Time of the day when the two will meet. So they will meet at what time? Let us now start bringing in the ideas. We said that overtaking time, OVT, this equals to the distance between the two over relative speed. So we need relative speed. Before you calculate relative speed, you ask yourself, are the two vehicles moving towards each other, approaching, or they are moving in same direction? In this case, the car is moving from Eldoret, the bus is moving from Nairobi. So they are approaching. So relative speed will be the sum of the two. So relative speed will be equals to 80 plus 120, which gives us 200 kilometers per hour. So the already we have our relative speed. What is the distance between the two when the two will start moving together? There is a 15 minutes. The bus started at 7 a.m. and the car started at 7:45. So what is the distance the bus has covered in 15 minutes before the car started moving? So distance is equals to speed times time. Speed in this case is of the bus 80 times time, which is a quarter. Year 1, year 20. So the bus has covered 20 kilometers before the car started moving. The bus has covered 20 kilometers. So which distance now is remaining? 300 minus 20. 300 minus 20 is 280 kilometers. That's the distance between the two. So what would be now our overtaking time? Overtaking time.
Excuse me,
Overtaking time. Yes.
sir, I'm finding 60 kilometers.
Let me check. 60 kilometers. Okay. Let's check. We are here. This is Betty who's talking, eh?
Yes.
Okay, let's get back. What is the distance? Distance is equals to speed times time. Eh? Speed of the bus is
80 kilometers per hour.
okay. Time?
3/4.
Oh, time in 45. I used a quarter. 45 was 60. That's okay. 60 kilometers. For me, I used a quarter. I read this one as 15. So let me rerun and learn. It is 45 minutes. So this one is 60 kilometers from the starting point. So the remaining distance, let's change everything. Remaining distance is 240 kilometers. Now, overtaking time. Overtaking time will be equals to distance between the two, 240, divided by relative speed, 200. And this one gives us 1 hour. And how many minutes?
$12 minutes.
12 minutes. 1 hour, 12 minutes. Now, when you have worked out for the overtaking time, get back to the question. The time of the day the two vehicles met. So we are not calculating, we don't celebrate at this level. What is the time of the day? So the vehicles started moving at 7:45, and they have taken 1 hour, 12 minutes to meet. So this one will give us 7, 5, and 8. They will meet at 8:57 a.m. Are we in agreement? I hope yes. That is, we have used the relative speed. Part C, the distance from Nairobi where the two vehicles met. Distance from Nairobi where the two vehicles met. Distance is equals to speed times time. Let us decide which to use. We are asked the distance from Nairobi and which vehicle is moving from Nairobi. We can approach the question from whichever way, but I'm advocating the one that will give us the answer kind of straight. Which vehicle is moving from Nairobi is the bus. The bus is the one which is moving from Nairobi. So speed of the bus is 80. Time taken for the bus and the car to meet is 1 hour 12 minutes. So it is 1 hour and 12 over 60. Here 1, here 5. So it is 80 times 6 over 5. And this one gives us what? Those who have calculators?
96.
96 kilometers.
Yes.
Remember, this 96, it is not the actual distance. 96, if we get back to our diagram, 96 will be somewhere here after covering 96 kilometers. So we have the 60 kilometers that initially the bus moved from Nairobi to somewhere. And then we have the 96 kilometers that the bus has moved in 1 hour 12 minutes. So in total, the distance will be equals to 96 plus 60, which gives us 156 kilometers. That is the distance from Nairobi to where the two vehicles will meet. The part D, the distance of the bus from Eldoret when the car arrived at Nairobi. The distance of the bus from Eldoret when the car arrived in Nairobi. Let's start now reasoning on this one. We have the two. We have Nairobi, we have Eldoret. There is nowhere we are told any other drama, whether they stopped, whether they did what. It is one way, it is very straight. So the distance from Eldoret when the car will arrive in Nairobi, the bus will be somewhere. Haitakuwa imefika. So what is this distance that the bus will cover? So time taken for the car to move from Eldoret to Nairobi is 300 divided by 120. So 300 divided by 120, we have 15 and by 2, 15 by 2, 6 by 3, 5 by 3, 2. So 2.5 hours. Not be the case, 2.5. 240. Okay. The distance. It takes 2.5 hours for it to reach from Nairobi, from Eldoret to Nairobi. In these 2.5 hours, the bus could cover which distance in 2.5 hours? So the bus will cover which distance in 2.5 hours? So distance covered by the bus is 80 times 2.5. 2.5, which is 2.5 hours, times 80. So then we'll cover 200 kilometers. So the bus will cover in 2.5 hours. The bus will cover 200 kilometers. So we started by getting the distance, the time taken for the car to move from Eldoret to Nairobi. It is 2.5 hours. In 2.5 hours, the bus will cover which distance? It will cover the distance of 200. Then you get back and remember that the bus had already covered 60 kilometers. Then in 2.5 hours, it will still cover 200 kilometers. So which distance is remaining? This one makes 260 kilometers. The distance which is remaining for it to arrive in Eldoret is 40 kilometers. So the answer should be 40 kilometers. We try to be realistic as much as we can. So in 45 minutes, we cover 60. Relative speed will come in. Then the bus will start, the car will start at 7:45. At 7:45, already the bus has covered some distance. So the 2.5 hours, 2.5 hours will be catered for 200 kilometers. But already we had the 60 kilometers. So it is 40 kilometers that will be remaining for the bus to cover to arrive in Eldoret. That's how we can address this question.
Tarudia hapo.
The last part.
Yes.
Okay. Let's do the analytical part of it. Let's get back to our original diagram so that we can draw it maybe. Our original diagram, we had this. That the bus started from Nairobi at 7 a.m. It covered some distance of 60 kilometers in 45 minutes. Now the bus is somewhere here, 60 kilometers from Nairobi. A car will start moving at 7:45. Then it will move direct to Nairobi. How do you find the time? Time tumesema it is distance over speed. Distance of the car, it will recover 300 kilometers. And the speed of the car is 120. So this one gives us time of 2.5 hours or 2 hours, 30 minutes. That's the distance, that's the time it will take to move from all the way from Eldoret to Nairobi, 2.5 hours. But remember, the 2.5 hours, the bus will also be moving. In the 2.5 hours, the bus will also be moving. So the bus will cover which distance in 2.5 hours? So which distance is it going to cover in 2.5 hours? So it will cover the distance of 2.5 times 80, which gives us 200 kilometers. So this 200 kilometers, it is from where the bus was at the 7:45 to where it will be after the lapse of 2.5 hours. So it will be 200 kilometers. But remember, we had the 60 kilometers initially covered in the 45 minutes. So the distance covered by the bus will be 260 kilometers. So what distance is remaining to cover the 300? It is 40 kilometers. So the 40 kilometers will be arrived at after such a considerations. Now, are we in agreement?
Yes.
Well, that is the question on linear motion, and it is touching a number of aspects. I think we can also try another question that you try and then it will come in. Trial 2, paper 1, question 19. I will give you some minutes to try. Trial 2, paper 1, question 19. It is almost the same. Now I want to see how you will handle the question. I want to give you a few minutes. You try the question. At least try the question. I must not be where you are to see whether you are trying, but I know you cannot run away from your God. 5 minutes. Try to scribble something so that when we come in, at least you know what you are doing.
Teacher, the vehicles are moving on the same direction.
Kiriari is a market center 600 kilometers from Kisumu town. A bus starts from Kisumu to Kiriari at an average speed of 80. At 8:30, a car started from Kisumu to Kiriari. The question is okay. Make a decision. Make a decision whether they are moving from where to where. Ah, very good. Where are we? Volunteers, give us a bit of what you have worked out. I want preliminaries. Roman 1. The distance bus covered before the car started moving. Roman 2. The relative speed for the two vehicles. 3. The time the car overtook the bus. 4. Distance covered by the car before overtaking the bus. Distance from Kiriari to the car at the time the car was overtaking the bus. It's specifically, it's just thinking. Who is ready to give us a few so that we know what we are working? Beth, I can see your hand is up. According to Beth, Roman 1, what's your answer?
120 kilometers.
Roman 2?
40 kilometers per hour.
Roman 3?
11:30 a.m.
Roman 4?
360 kilometers.
Number 5?
240.
240.
Yes.
Okay. Another person with other answers apart from what Beth asked? Nobody. Let us work together and see whether we can arrive at the answers that you are having. Kriari is a market 600 kilometers from Kisumu. So 600 kilometers from Kisumu. A bus starts from Kisumu for Kriari. A bus starts from Kisumu. This is a bus. And at an average speed of 80 kilometers per hour. At 8:30, a car started from Kisumu to Kiriari. A car started at 8:30 from Kisumu to Kiriari. moving at an average speed of 120 kilometers per hour. So the two vehicles are starting from Kisumu to Krieri. First question, the distance bus covered before the car started moving. Distance is equals to speed times time. Speed of the bus, 80. Times time, the distance bus covered before the bus started moving. Times the distance times time. Time is 1 hour 30 minutes. 1 hour 30 minutes. So it is 1.5 hours times 3/2. Here 1, here 40. 120 kilometers. Beth, that one we are in agreement. It is 7 minus 8:30, which gives us 1 hour 30 minutes. So between the 1 hour 30 minutes, the bus has moved 120 kilometers. Now our bus is here and our car is at Kisumu. The relative speed for the two vehicles, relative speed, they are moving in the same direction. So relative speed is equals to 120 minus 80, which gives us 40 kilometers per hour. We are still okay with that. The time the car overtook the bus, which is the distance between the two, 120 kilometers. So overtaking time, OVT, is equals to distance between the two, 120, over relative speed, 40. This one gives us 3 hours. Time the car overtook the bus, they started moving at 8:30. So 8:30 plus 3 hours. This is 11:30. So 11:30 a.m. The distance covered by the bus, by the car, before overtaking the bus. Distance covered by the car before overtaking the bus. Distance is equals to speed times time. Speed of the car, 120 kilometers per hour. Time taken, 3 hours. This one gives us 360 kilometers. That's good. Distance from Kriari to the car at the time the car was overtaking the bus. Let's get back here. Overtaking took place at 360 kilometers. That's the cars moved 360. And the bus will move which distance? The car has covered 360 kilometers. And the question is the distance from Kriari to the car at the time the car was overtaking the bus. It is 600, which is the complete distance, minus the distance covered by the car, which is 360. This one gives us 240 kilometers. I think now we are in agreement. Any question so far? Let us find one that is talking about the graph and see how we can deal with it. Let me check whether we can get one that's talking about the graph. Trial 3, paper 1, question 17. It's a replica of what we have worked out. Trial 5, paper 1, question 20. Question 14. We have question 14 here.
Trial paper.
Or trial paper, let me check. Trial paper 8. Question 14. Let us see how it is behaving. Trial paper 8, question 14. Question 14 saying the figure below show a velocity time graph of a wagon. Find the total distance traveled by the wagon. For how long did it maintain a constant speed? This is a velocity time graph where we agreed that distance is equal to the area under a graph. So the area under a graph, this graph is in form of a trapezium. So we need to find the area. So the total distance, it is the area under the graph. So trapezium from here to here, we have 20 minus 4, so we have 16. From here to this one, we have 24. And the height of the graph is 80. So area of a trapezium is equals to 16 plus 24 divided by 2 times the distance between the two. It is average the sum of parallel sides times the perpendicular distance between the two parallel sides. So this one gives us 40 divided by 220, 20 times 80. This one gives us 1600 meters. That is the distance. It is as easy as this if you remember these concepts. That when you are asked in velocity time graph, you are asked to determine total distance traveled. It is area under the graph. How long did it maintain a constant speed? For how long? Constant speed, we said here we have acceleration. On this one, we have deceleration. And now the constant speed is along this one. For how long? 16 seconds. It is the 16 seconds where it maintained an average speed. We can add a few questions. What is the acceleration? Acceleration is equal to final velocity minus initial velocity divided by time taken for the change. Our final velocity is 80 meters per second minus the initial velocity, which is 0. Time taken for the change, it is 0 to 4. So the acceleration is 80 over 4, which is equals to 20 meters per second per second. If it is a deceleration, it will be the same. Deceleration is equals to the final velocity, which is 0, minus the initial velocity at this stage. So this is where we have deceleration. So final velocity is 0 meters per second. Initial velocity is 80 meters per second, divided by time taken, 24 minus 20, which is 4. This gives us negative 20 meters per second. So we call this one deceleration. Wonderful. Let's see whether we can get another question of the same, which is a bit comprehensive. We have trial paper 10, question 20. Trial 10, paper 1, question 19. It is the same thing like the ones that we have been working out. I don't think whether we have another one. Trial 9, question 18. Jaribu hiyo ya mwisho. Trial 9, question 18. A commuter train, it is the same as the one that we worked out. Haya, tuko. Susan.
Yes.
Good. I wish that you go on and try other questions on linear equation. Let us now try something that is on that are on linear motion. Tuende kitu inaitwa linear inequalities. Linear inequalities. Linear inequalities. Linear inequalities number 1, what are we expected to know? It is inequality symbols. It is one everyone is aware, less than, greater than, less than or equals to, greater than or equals to. They are 4. Number 2, we are supposed to know how to solve an equation that is inequality that is called the compound statement. Compound statement. Compound statement is like x is less than or equals to 6, greater than or equals to -1. But it's not this straight. It must be given from some original state, and then we are required to to solve and give this one. Number 3, we are supposed to know how to present the solution on a number line. Like what we have on this case, we have 6, 5, 4, 3, 2, 1, 0, -1, and 2. How can we represent this one on a number line? We circle the boundaries. Well, first the boundary is 6. Another boundary is then if it is less than or equals to, greater than or equals to, we shade the circle. If it is less than, greater than, we do not shade. So our inequality is less than or equals to, so we shade this one. Our inequality is less than or equals to, we also shade this. And then we draw a bold line between the 2 boundaries. So we have represented this one on a number line. Number 4, we are expected to get this one, and we state integral values. If we have solved and we have x is less than 5.5, x is greater than or equals to negative equals to 2, how can we state integral values? For less than or equals to, greater than or equals to, include whole number boundaries. That's for less than or equals to, include the whole number boundaries. For less than, for greater than, we don't include boundaries. So for our statement here, what are the integral values? Our first boundary is whole number, and it has less than or equals to. So our first integral value is 2. Then we have 3, 4. We move to 5, but it is 5.5. So 5 is included. We don't include 5.2 because it is a fraction, it's a decimal, and we only include all numbers. We are approaching 5.5 from this end. We meet 5 first before we go to 5.5. So this 5 is included in the integral values. We have to be careful when we have fractions. Now the last bit of this one that we are supposed to know, it is formation of inequalities. And this one, it is from graphs. Am I back? Somebody confirm?
Yes, lakini hatuoni screen yako.
Okay. Something is not adding up from my side. Now I'm back. I said we need to know how to form inequalities from a graph, and we know how to do graphical representation of inequalities. And on a graphical representation, we know that when we have less than, on the graphs, when we have less than equals to, greater than equals to, we draw continuous line. And we shade the unwanted. When we have less than, when we have greater than, you draw the broken line. Having such information in mind, now I want us to try maybe a few questions if we can see any. Linear inequalities, trial 1, paper 1, question 4. Trial 1, paper 1, question 4. Trial 1, paper 1, question 4. Find the integral values, qualities. We have two inequalities. I want us to start solve the two. It's very easy. Solving, we have 15 minus 2x is less than 4. We take this one to the other side. Negative 2x is less than negative 11. That is 4 minus 15, negative 11, over negative 2 over negative 2. X is greater than 5.5. I want you to note that when we divide by a negative, the inequality sample will change. Dividing by a negative value, the inequality sample will change. Now it was less than, we make it greater than. We do the same for less than 3x minus. Yes?
Yeah, but before the original question, the sign was greater than.
Oh, I'm the one who changed. Okay, let's get back. It is greater than, greater than. Now it will be less than. In agreement?
Yes.
Yes. So we move to the second one. 4 less than 3x minus 2. Every time we tend to bring the unknown to the left hand side, so it becomes negative 3x is less than 4 to go to the other side, negative 6. Divided by negative 3, divided by negative 3. Dividing by a negative, the inequality sign will change, and that one now becomes 2. We like force. Here now we are forcing issues. All the time, have you unknown on the left hand side with the one weapon. If it is negative, as we divide all through by something, the inequality sample will change. Now let's combine the two. We have x, which is less than 5.5. We have x, which is greater than 2. The question is, state the integral values. We agreed somewhere that include the whole number boundaries. I'm insisting whole number boundaries if the inequality is less than, greater than, or greater than. So in this case, we don't include 2. We start from 3. We go to 4. We go to 5. And after 5, that's when we go to 5.5. So the 3 integral values are 3, 4, 5. We don't include 2 because it is the inequality sample is less than. We don't include a boundary because 1, it is a fraction, it's a decimal, and it is not an integral value. Integral value, we are referring to whole numbers. Whole numbers satisfying a given inequality. Next question, linear inequalities. We have trial 2, paper 1, question 12. Trial 2, paper 1, question 12. This one deals with formation of inequalities. This one I want to be very categorical. I want to give the steps. If the lines are not labeled, you label them. You will label them by saying you call this one L1, you call this one L2, and you call the other one L3. Then now you embark on getting the equations for the two. Let's start with L1. L1, you make observation. Is the line continuous or broken? You say L1 is broken. So we want to use the inequalities, less than and greater than. Form the equation of this straight line. The equation of this straight line, we choose 2 points where the line is passing through. The line is passing through 8, 0 and negative 0, negative 6. 8, 0, 0, negative 6. And they are the intercepts. So we form the equation of this straight line. The line is passing through 0, negative 6 and 8, 0. So we want now the equation for this one. Gradient, change in y over change in x. 0 minus 6 over 8 minus 0. This one gives us 6 over 8. The same as 3 over 4. That's the gradient. Equation of straight line. Y is equals to mx plus c. Ym is the gradient. Y is equals to 3 over 4 x plus c. C is the y-intercept. Where is the line cutting the y-intercept? Negative 6. So y is equals to 3 over 4 x minus 6. So we have the equation. From the equation, make it to be an inequality. Choose 1 point inside the region. 1 point inside the region. preferably the easiest one. I will choose this. I will choose -1, 0. It is very easy to substitute this one. -1, 0. Choose one point inside the wanted region. So it must satisfy all the inequalities. So after choosing one point inside the inequalities, I have chosen -1, 0. So substitute -1, 0, and it must give us a true statement. So y is 0. You skip some gap, and x is -1. Weka -1 hapo, it will be -3/4 minus 6. -3/4 minus 6. At least it has some values which are negative. Which statement is true? 0 is less than -3/4 minus 6. That one is false. Because from on the number line, -6.75 and 0, which one comes first? From the number line, we get -6.75, then we get 0. Any number to the right of the other one is greater. So 0 is greater than -6 and 3/4. So our inequality, we get back to the equation. Now, instead of writing the equation, you write the inequality. So our first inequality, L1, is y is greater than 3/4x minus 6. That is the inequality that we want. So I want you to mark the steps. Check whether the line is continuous. If it's not continuous, you choose which inequality sample to use. Take 2 points where the line is passing through. Get the gradient. Substitute the gradient in y is equals to mx plus c. And then form the equation. Bring the inequalities in by choosing one point. What?
You repeat the steps zenye unasema sahi.
Okay, the steps, eh?
Yes.
Step number 1, you check whether the line is continuous or broken. This will inform you if it is continuous, we have less than or equals to. If it is greater than or equals to. If it is broken, we have less than, we have greater than. Number 2, you take 2 points. The 2 points will help you to know the gradient. You calculate m. Number 3, substitute gradient in the form y is equals to mx plus c. The gradient and the 1 point xy. Number 4, from the gradient you form an equation. From an equation, number 5, you choose 1 point inside the wanted region. A region that satisfies. Then number 6, you test. After testing, you choose which inequality to use, and then you substitute in the equation. Instead of the equal signs, you replace with the inequality symbol. With the same steps, let us go to line 2. Same steps, line 2. Line 2 is passing through 0, 0. It is also passing through, we choose any point where it is passing through. Nimeona hii. I'm seeing -2, 2. Line 2 is passing through 0, 0. And the line is continuous, so we have less than, equal, greater than, or equals to. That's the analysis of line 2. Line 2 is passing through 0, 0. It is passing also through negative 2, negative 2, 2. It is also continuous, so we are going to test for less than or equals to, greater than or equals to. So what is the gradient? Gradient is equals to change in 2 minus 0, negative 2 minus 0. This one gives us 2 over negative 2 is equals to negative 1. That is the gradient. Substitute gradient in the general form of equation of a straight line. Y is equals to mx plus c. Y is equals to negative x plus c. C is the y-intercept. The line is cutting the y-axis at 0. So our equation is y is equals to negative x plus 0. Y is equals to negative x. That's our equation. Take 1 point inside the wanted region. Tumechukua negative 1, 0. Negative 1, 0 was the easiest one to substitute. So we have taken negative 1, 0. And because it is in the wanted region, it must satisfy. Substitute 1, 0 in this equation. 0, and then skip some gap. Substitute 0, x is negative 1, so negative 1 into negative 1. So 0 and 1. It was continuous, so we are using this one or this one. 0 is less than or equals to 1. True. So now our inequality for line 2, we substitute here. Instead of equal signs, unaweka the inequality sign, but that is giving us a true statement. So y is less than or equals to negative x. That's our line 2. So our inequality line 2 is y is less than or equals to negative x. That is second inequality. If you have the steps right, you can even do them very fast. Line 3. Line 3 is continuous. So we are going to use less than or equals to, greater than or equals to. That's number 1. Line 3 is continuous. Line 3 is take 2 points where the line is passing through. It's passing through negative 4, 0. It is also passing through negative 4, 5. You can see 4 is constant. Even if we work out the equation, it will still give us something. 4 is constant.
I have a question.
Yes.
5 umetoa wapi kwa hiyo negative 4, 5?
Oh, negative 4. I've marked where negative 4, 5 is. It is also passing through negative 4, negative 4. Negative 4, negative 5. It's a constant. It is passing through anywhere, any point. There is a negative 4 along that line. So this one tells us that it is the equation x is equals to negative 4. It's a constant. Negative 4 is constant everywhere. Any point you take along that line, there must be a negative 4 something, negative 4 something. What is changing is the y, but x is not changing. So it is the line which is x is equals to negative 4. A line perpendicular to the x-axis passing through 4. So this is our equation. Take a point inside the wanted region, negative 1, 4. Negative 1 is 0. Substitute here. 4 is negative 1. Nothing. So negative 1, skip some gap, negative 4. Between negative 1 and negative 4, which line, which number is bigger? Negative 1 is bigger than, we get negative 4, negative 3, negative 1, negative 1, then is 0. Anything comes before another number from left in the x-axis, in the number line, it is bigger. So negative 1 is greater than negative 4. So our inequality is greater than or equals to. So we get back to the equation, and our inequality becomes x is greater than or equals to negative 4. We have the 3 inequalities, and those are the steps that we must observe as we are trying to make things work. Great. Any question?
Excuse me, Cha, you see, Cha hapa kwa line 2 ulisema ina pass through 0, 0 and negative 4, negative 2 and 2. Sasa hapa negative 2 and 2 ina pass aje hapo hiyo line 2?
Oh, line 2, negative 2, negative 2. Let me try to magnify this thing in the Beth.
Yes.
Now in my magnified figure, take negative 2, 2.
Yes.
Sinapita huko.
Cha, kwa nini basi usiseme negative 5, 5 ama ticha unaweza sema?
Yeah. Unaweza sema our intention is to get 2 points, eh?
Oh.
Even if you take negative 5, 5, even if you take negative 3, negative 3, it will still serve the same purpose. We only interested in getting 2 points, eh?
Yes.
For getting the gradient. Sawa.
Yes.
Another concern? Any other concern? Now I want to give you one that you can try. Test paper. You want to try your paper 2? Trial 4, paper 1, question 11. Number 11. Nataka mutafute hizo.
Trial
4, paper 1, number 11. By now you are done. Somebody to give me the inequalities to answer na hiyo. Come to this one. And then this. The others will confirm. Raise up your hand. Unmute and give us what you have. I don't want to say inequality 1. Yes, somebody? Let me call this one in your equation 1. Wherever you have written, na ika equation 2, na ika inequality 3. So inequality 1, somebody to give us the working. Haya. Trials are allowed. Haya. Fellow Kenyans. I will start calling names. Susan, what do you have? Candy, what do you have? Hi, am I communicating? Mtu wa confirm. Mnanisikia? Mercy, am I communicating? Am I the only one here? Debbie? Beth, am I communicating? Oh, kumbe mnanipata. Majibu ndio hamjafikia. Brenda?
Bado.
Bado. So I give you time. Kwani kulienda aje? Hata equation 3. Equation 3 is the easiest. Equation 3 is the one, it is continuous. So less than, greater than, or equals to. It is along the x-axis. So it is the equation y is equals to 0. Take 1 point inside the region 0, 1. It is the easiest to substitute. Substitute 1, 0. It is obvious. 1 is greater than or equals to 0. Get back to the equation, substitute. Y is greater than or equals to 0. We have line 3. Hii yenye iko hapa. I'll give you another one. Line 1. Line 1 is passing through 0, 4. It is passing through negative 2, 0. Line 1 is continuous, less than or equals to, greater than or equals to. Gradient m is equals to change in y over change in x. 0 minus 4, negative 2 minus 0. So negative 4 over negative 4, negative 2, 2. The gradient is 2. Y is equals to 2x plus c. Where is the line cutting the y-axis? At 4. Y is equals to 2x plus 4. Choose one point inside the region. We have taken 0, 1. Substitute 0, 1. Substituting 0, 1. 1 is 0 plus 4. 1 is less than or equals to 4. Substitute in the equation. Our equation becomes y is less than or equals to 2x plus 4. That's another one. You move to the line 2. Line 2 is continuous, less than or equals to, greater than or equals to. It is passing through 4, 0 and 0, 4. Gradient, change in y over change in x. M is equals to 4 minus 0, 0 minus 4. 4 over negative 4, negative 1. Equation, y is equals to negative x plus c. It is passing through 4. So y is equals to negative x plus 4. We have taken 1 point, 0, 1. Substitute here, 1 and then 4. 1 is less than or equals to 4. So our y, our inequality becomes y is less than or equals to negative x plus 4. That's another inequality. What is challenging in this corner? I think you must be having this one. I want to give you another question that you will try. Linear inequalities, trial number 7, question 8. Trial 7, question 8. Trial. Trial 7, paper 1, question 8. Yo. Using the same procedure. I want to see you struggling with this.
Yeah.
Work out this. What's wrong? Hey. You don't want to get tired? Nani ameshtuka? That one must be Ibedhi ameshtuka. For guiding ourselves, hii ndio ikae. They are labeled line 1, line 2, line 3, and there must be line 4. 1, 2, 3, and line 4. Mimi nikiona hivyo, I will start with line 4. Because line 4, it is the equation x is equals to 3. I take 1 point inside the region. I substitute. I talk about it. What are the answers? Maybe line 1? It wasn't line 3. Somebody to give us line 3. It is trial. It is trial what? Tulisema ni trial 7. Trial 7 paper. Trial 7 paper 1. Question 8. Let me illustrate the answers. Trial 7. The answers to see your work. This trial 6, trial 7. Question 8. Yes, here we are. You should have something like that. But let me mention something. You don't have to leave your answer in this aspect. Always try to give your answer in the form y is equals to less than or equals to mx plus c. Something start with y. That's what the examiners will easily see. Like this one will be y is, take everything to the other side. Y is less than x plus 1. This one the same will be 3y is less than or equals to negative 2x plus 12. Y is less than or equals to negative 2 over 3x plus 4. Something like that. I want us to stop at this level. I wish you well in the coming sessions.